This is Sean Browning, and he says, "Hello, this is Sean Browning. I'm coming from Hood River, Oregon.
Hood River, yeah.
Why does cesium have such a violent reaction when exposed to oxygen? And what are some of its practical uses that the average person would not know about?"
Okay. In the periodic table is kind of shaped like a U. And so cesium is in the bottom left-hand corner. And so the bottom left-hand corner is where your biggest atoms are. And so cesium is really big. And what that means is it has a very, very positively charged core, its nucleus, but its electrons are very far away. So it can barely reach the electrons. And so because it's so big and their charges are so separated, oxygen, which likes to take electrons from a neighbor.
Thief.
It is, exactly,
It
yes.
loves to steal electrons.
It will steal the electrons.
Yeah.
But yeah, so it's so big. And so that's oxygen can come in, grab the electrons, and the electrons gladly jump to oxygen because it's much, much smaller and it can reach
Cesium,
its
I'll
charge.
see you later.
Yeah.
Okay, so now it reaches for oxygen. What is the result of that chemical reaction? Is it exothermic, endothermic? What?
Probably exothermic would be my guess. It really depends on the situation and where their energy levels are. It will form an ionic salt, and so it either forms cesium oxide or cesium superoxide. So just either two cesiums and one oxygen, or two oxygens and one cesium, and it forms these two products, and that in itself is quite stable. The oxides usually are.
So what does it look? What does this? Because he said violent. What does this violent reaction look like?
So my guess is he's thinking about when you throw these group 1 metals into water. So we've seen this with sodium before, if you've Googled that.
But that's reacting with water.
It is.
Or is it the dissolved oxygen that it's reacting with?
It's the same process that's happening. It's the electrons being pulled from the group 1 metal.
Got it. All right.
Yeah,
All
and
right.
then it's an exothermic process, like you said, so that will ignite when you throw it in water. So,
Okay.
But the other part of the questions you asked about, what are some things that people might not know about cesium?
Right.
And so cesium 133, I think, is used for an atomic clock. And so what happens is you basically disturb these atoms, they give off a frequency, and you can use that frequency to measure time.
And how are you exciting the atoms?
It's a disturbance, so usually it's like a push. You want to get it to vibrate, and so you just have to move it a little bit. And that frequency is then mapped out to keep track of time, and it's so...
So is it so consistent that you can easily use it? You can set a clock by it.
Nice. Exactly.
In fact, the duration of the second is defined by how many cycles of the cesium atom